Hello and welcome to CherrySTEM 29. And we are your hosts, Anna Cherry and Richard Rall, and we will be talking about science news. So we've had a bit of a rebranding, a little bit of a change of direction, if you will. Everything is essentially still the same. We're still going to just nerd out about science that we like. But this time is going to feature a little bit more of a recent event, recent news and science sort of spin to it. So that way we can keep up with the latest happenings as well as, inform you guys about it. So I would like to show you guys something that isn't working for me right now. Sorry about that.
Let me show you how this doesn't work.
Yeah.
Isn't that entertaining?
Isn't that great? So I have here, for your viewing pleasure, the, that's what happened. There we go, my bad. All right, so this podcast, this live show, this everything is sponsored by viewers such as yourself. So I would recommend you guys to check out patreon.com/AnnaCherry. That is where you can support this specific podcast live stream right here and help us make more of them, as well as get awesome goodies in return. So check out Patreon. I would recommend the tier you see highlighted here before you, the Challenger tier. I would highly recommend that one for you all beginner supporters. Check it out. Follow us on there because we upload the CherrySTEMs on there as well. You can download the audio files. You can get the RSS link if you are a patron. The audio files are available publicly, so you guys get this awesome podcast both as a video and as an audio file through Patreon. That's where the magic happens. Become a patron, share in the magic. It's great. So yeah, that's my show for the day, and let's get into the news.
Cool. So is that my cue to try to bring some things up here?
Let's do it.
All right. Well, apparently SpaceX's Starman and its Tesla Roadster are now beyond Mars. It's about at the, was it aphelion? They don't specifically say there. That's just the term for its furthest point out from its orbit, which it is orbiting around the sun. So it's just one of the things it's going to be doing is orbiting out past Mars and then kind of catching up with the inside of the Earth's orbit. So that's a neat little thing that's going to be out there doing. I found it entertaining anyway.
So that's the Roadster is essentially a brand of his car.
Yeah,
right. And so
apparently
they just launched
he was actually driving the car beforehand, so it was his car that he launched.
So he launched his car into space.
Yeah, because normally what they do is
That's
they put
awesome.
they put a dummy load on there.
Oh.
Because
So it's gotten frisky quickly.
No, I thought it's literally there's a dummy driving the car.
Well, where's the load coming from?
Oh, I don't know. I don't know. But
That's
they
what
put that
I.
on like rockets to
Right.
test, like, because they didn't want to put anything more expensive.
Why do they need to have a dummy load?
It was just to test a new type of rocket that's inexpensive but can put big loads into space, launch huge loads into space.
So, an
The whole idea.
inexpensive rocket to launch loads.
Right, exactly.
Cool.
And so it was a proof of concept
Hmm.
basically, and so they launched that out there, and that's neat. One
So,
of the
so his
things
car is floating in space now.
it's out
So
there.
we're throwing our trash in space now, is what you're trying to say.
And apparently, oh wait a minute, no, some of the things it's going to be there for a very long time. What was it? There there is a
Space
there's a
doesn't
6%
biodegrade.
chance of it hitting the Earth in the next 1 million years, and a 2.5% chance of it smacking into Venus during that period too.
Thanks, Elon.
So there is a possibility could end up, but no, it's in a very very long perpetual, theoretically perpetual orbit. So that's a neat thing. What was one of these other neat things that I ran into? Oh yeah, Oumuamua. I don't know how to pronounce it.
Oumuamua.
Oumuamua. I don't know. You gotta like do the hula as you say it.
Oumuamua.
Okay, so there was this this object that
So
entered our,
that, could you? I've meant to. So sorry about this. I meant to ask you about this beforehand, but I forgot. Some links, if you would like to send them to me, I can actually feature them on the screen. So if there's anything in particular, like the weird pronunciation or anything else, visual aid that you want to have available on display, let me know. Send it to me.
Okay. Well, so here's the thing. There, our first interstellar, like we know for sure, it's an interstellar object. It was this thing, this long, thin, is what we presumed it was. You can't really see it per se as much as you can detect
Oh.
light coming off of it and do some interference.
It's-
It's this huge, long, thin, strangely shaped object coming from interstellar space,
How many-
entering our solar system.
How many loads can it deliver?
A lot of loads. And so at first they were like, okay, it's just an asteroid from another star system. Then they're like, well, no, it's got to be a comet because it's accelerating. It's doing this thing that it shouldn't. It's changing its trajectory in a way that is like that doesn't make sense basically, and so it must be a comet. Then, however, as it got closer and closer to the sun, they realized it cannot be a comet. There was no outgassing, and so that left us with a very interesting mystery because it was accelerating and was not accelerating by the use of outgassing of basically what happens with a comet is as the sun melts the water, and you have water vapor and things like that being shot out into space, then it can end up slowing down some because of the gases that are being given off by the comet, which gives it its tail and all of that. And so that makes sense why a comet would behave in the way that it should. But this was doing that sort of acceleration thing, and not only that, after it left the sun, it should have, based upon the way that the orbit worked, it should have slowed down, but instead it sped up. So first off, the way it was approaching the sun, there was acceleration that didn't make sense, and then when it left the sun, there was acceleration that really didn't make sense. And so there's real scientists out there saying, well, maybe this is an ancient light sail that was sent from another, some other advanced species in another, part of our galaxy. So there's a light sail it's basically what you do is you create something that can catch the pressure of light itself, the photons coming off, and like if you've ever seen one of those little, it looks like a little light bulb with these little, it's called a radiometer, I think, with these little. It looks like a little windmill inside of a light bulb.
Yeah, I've seen that. Mm-hmm.
Yeah, well, basically that's responding to the pressure of light. And so the idea is that a light sail is something that you can create. There's this huge, thin, thing
Oh, I see.
that you could have in space that would catch light, and it's one of the ways that they propose. You know, we can shoot a laser from the Earth into a light sail to accelerate a spaceship, you know, into interstellar space at a very high rate of speed, which is why they are suggesting that perhaps this interstellar object is actually an alien artifact. So there is no explanation. The common explanation of it being a comet or it being an asteroid makes absolutely no sense based upon its behavior. So that's really neat. I found that.
So that happened.
Yeah, so that happened. We may have. There'll be no way to really know. There's some plans to go try to catch it.
We're gonna Moby Dick that thing.
Yeah, we're gonna chase it down. But yeah, there's some plans that there's the possibility that we could send something out to catch up to it and study it. Wouldn't that be great if we sent cameras out there and it shot down our whatever we sent down? Wouldn't that be cool?
Spooky.
Oh man, that would be awesome.
I think your definition of awesome and some other people's may be slightly incongruent.
So that's cool.
Not that I'm one of those people.
That may be our first discovery of an alien artifact. That's neato. I find that to be good news. Anyway, so then one of the other things that was apparently in the news here was that DARPA dropped. It's a minuscule amount in the total budget of DARPA.
Just real quick, DARPA is cool and terrifying, and really cool and really terrifying, and really cool. So what's DARPA? For the viewers who may not be familiar.
Defense Advanced Research something.
Project.
And I don't know. They can look it up. DARPA is basically the science wing of the military.
So they research some really neat shit that is like science fiction, but for the military.
So they only put 1.4 million. It's such a pittance.
Oh, that's tiny.
But
you said million with an M.
Yeah, only a million.
Oh.
But on the Impossible drive, the EM drive. I don't know if anybody's looked into that, but basically the EM drive was something that ended up being tested in labs in the U.S. and labs in various places. And there was a lab in China, and these are all, NASA tested it, and it was producing acceleration by a method that, according to our physics, it shouldn't. Now, the thing is, that should, there's people who would be, oh my God, then it can't work if it doesn't work according to our current physics. Mm-hmm. And then there's people who realize that our physics is failing in a number of places, and you're having all of these different problems with our physics theories where we're showing, obvious model crisis, and one of them is called the vacuum energy catastrophe, where you can't say like millions or billions or anything like that, the number of how bad off we are. You have to use scientific notation to show the difference between what we actually detect and what we predict based upon our current physics. So there's a variety of ways in which our physics is at model crisis, and we need a revolution. But
that's actually coming up in the second part of the show, relevant to what we talked about in CherrySTEM number 28. So if you're interested in quantum physics, multiverse theory, string theory, things like that, pilot wave theory, alternative explanations, etc. This is a little self-promotion here, self-plug. Go check out CherrySTEM number 28. And that's available both on a YouTube live stream replay as well as patreon.com/AnnaCherry, where you can download the audio files and browse all our supplementary resources for each show that we do. So check out the CherrySTEM hashtag on Patreon, and back to DARPA and model crisis.
Okay. So they only dropped 1.4 million onto it, which is, for your average Joe, that's a lot of money, but when it comes to military science, that's meh in the way of total amount of money. But it's still something. It's 1.4 million, but the thing is, it's the last I heard about the news about it is they found that there was a bias that was sort of north and south. Now the thing is, if there's a north-south bias, then that's kind of, it aligns with the magnetic poles. Then that would, to some people, be, well, there it is. We finally found what we were looking for. It's just an error in the equipment or something like that. And the issue I have with that is that it's not necessarily caused by the effect of the magnetic field causing the acceleration that they're getting, but instead it is aligning to the magnetic field, and that is, I think that's why it's still being funded and it's still people taking it quite seriously, is that it's simply the alignment with the magnetic field that can change it, and that of course makes perfect sense that it could. It's in no way some sort of proof that it's just some experimental setup error. So I mean to get on to my favorite topic. Let's talk about. I'm going to jump aside here to old physics and the basis of modern theory, and the places at which it may be wrong, and that is in the original Michelson-Morley experiment. Michelson and Morley, they did their experiment over 3 days, the 1887 version of it. This is the experiment that is supposedly it is the impetus for special relativity, because it came through Lorentz is who came up with the change factor to explain the Michelson-Morley, which was theoretically null. But so why am I bringing this up is because there actually was a positive reading in the original Michelson-Morley experiment. Now, what Michelson was expecting was an east-west wind, and so he only gave the reading for the east and west.
And so what he was expecting of a wind that we're mentioning is actually an ether wind, which is the idea, especially if you watched our last show, CherrySTEM 28, you will be caught up on essentially what we're talking about, but a quick primer for those who are new or just tuning in is essentially the fabric of reality, the thing that light propagates and travels through, etc. The light waves. What waves the light is ether, is the sort of the medium, the Higgs field, the quantum foam, the whatever substance.
There's a million different ways in which
substrate of our reality.
The properties of the quantum vacuum, or the variety of ways in which they
terms,
put it. It has properties, and
they were trying to detect it.
And and even the idea that the ether isn't there is absurd. In 1920, which is 15 years after special relativity and 5 after general relativity, Einstein talked about that space without ether is unthinkable. That was his specific quote. It's ridiculous to think that space does not have very specific properties, and furthermore, he specifically called it ether. And there's a lot to the history there that I don't want to get too much into, because I'm kind of losing the thread here of what it is that we're trying to get.
Well, we're essentially talking about Michelson-Morley and the fact that there was a reading.
Right. So there was there was a reading. It was just smaller, much smaller than expected, and probably related to the fact that it was done in open air and was done with white light. I won't get into how the only thing I want to get into here is that the experiment that Michelson did was only replicated by Dayton Miller, because nobody else used white light, nobody else did it in an open air. They did it in a vacuum. Now, if Lorentz is correct, and I believe he is, about the way that the ether works, and this means that we don't change the math, we just simply change what we believe that the math means, and that is that there is an ether there, then well, I'm kind of losing my train of thought here.
Well, it all started with essentially that there's a model crisis, and it's related to the DARPA thing, and then we're talking about the EM drive and the speed and for which it was going.
Oh no, okay. So what I was just trying to explain is the Michelson, the non-null.
Right.
Then what would happen is there's something called ether drag, so that matter would actually drag the ether slightly, and so you'd get an effect in one direction or another that would be an ether wind, but it wouldn't be a full ether wind. It would be an effect caused by the air having dragging the ether. But all that aside, I'm saying this because we're talking about a bias in the EM drive that is north-south. What the original Michelson-Morley experiment detected was a wind of around 10 kilometers per second in a north-south direction. And then what Dayton Miller's tens of thousands of replications of that experiment also found was a north-south bias in the direction of the wind along the direction towards the North Pole. So the non-null of the Michelson-Morley experiment and all of the replications of it that were also non-null they all had a bias that was north and south, like the bias of this the EM drive. So the point is that if Lorentz is right and we don't change the math at all, we just accept what Einstein was saying, that constancy is not actually correct. There's a limit to that idea and it doesn't apply to general relativity, and there is a preferred frame, then it makes sense why it would be doing what it's doing. It makes sense in context of all of the history of physics as well.
And of course, if we look at what actually, like what space is propagated by, or
Mm-hmm.
what propagates space, or like what propagates. I don't know if propagates is the right word.
No, I think you're using the wrong word there.
But if just in other words, I'm trying to get at a question, I suppose, is that if we consider the ether approach, would we be able to travel?
Using something like the EM
Right.
drive, absolutely, because the point is that if there is something there, in if space is something, in other words, what is a rocket engine reacting off of when it emits energy in space? Why are you capable of it? That was one of the things when I was a kid. It's like, okay, I understand when you're pushing off the ground with your the stuff coming out of your rocket. I understand when you're pushing off the air with something coming out of your rocket, but when there's nothing out in space, what are you pushing against? That's it. There's problems with that perspective, but the point is that there is something there. So
Fundamental
therefore,
truth to.
being able to understand the first off, what it is that is in free space. If we there is a tremendous amount of energy in free space. This is also known as like there's something called the Casimir effect, 0 point energy. All of these things are parts of science where we know that there is something about free space that we do not quite understand properly, and what I'm saying that is ether, of course. Um, but that being said, the point is that of course we could use something like the EM drive to be able to go through space. If the ether itself, which we must presume it does pass through matter to some extent or another, as well as get dragged along by it, um, then you should be able to, even though the EM drive is something that is closed and theoretically shouldn't be able to react against anything, it is actually reacting against the ether. So, it's just a perspective of why something that theoretically is possible actually is possible with a very small change to the way that we see our current physics.
Yeah.
I mean, it's a large change conceptually, but there's no change. In other words, the way in which you do any of the calculations doesn't change. The math doesn't have to change for you to use preferred frame physics, fluid mechanics, and be able to understand what's going on from a different perspective.
And of
It's just
course, we'll get into more of that um, in the second part of the show, where we talk about the recent news that got exploded across our timelines a day after we did our live show, CherrySTEM, on pilot wave theory. So
yeah.
we'll get into that.
Okay. Then let's see.
All right, back to the news.
Back to the news. Some of the other, like, going to different kind of science. The was some archaeology stuff here. I thought was pretty funny. That apparently I remember a news story which I don't have in front of me right now, where one of the oldest bathroom jokes was first found, and now they found that there were
What do you
these.
mean by a bathroom joke?
In other words, it was like there was some scribbling on a wall in an ancient bathroom that was found.
Okay.
Well, apparently that was a commonality to very, very ancient civilizations. Like this one's from 1800 years ago. That there were dirty jokes in the latrine mosaics that the Romans have, and apparently it was like there were image jokes. So let's see, what was there were images of specific gods. Like in one case, it was Narcissus staring at his own dick. And was one picture, and then another one is something that's probably lost on us because it has to do with Ganymede. But it had to do with Ganymede and boy lovers in Roman times.
Oh, good
so
times.
yeah.
Those
So
Roman times.
So there was some joke, having to do with sponging off a boy's dick or something. I don't know. So, but that's the picture of the bathroom jokes. So
That's very Roman.
yeah, yeah, it was very Roman. So I thought that was something we needed to talk about
That's
there.
fantastic. I love it. I love it. So that's some of the, we can feel our ancient, noble
Noble
Roman
ancient
ancestors
Roman. By their
when we
bathroom
go to the
jokes.
bathroom stalls and see all the scribbling all
Yeah,
around us.
and
We
like,
can
it's like,
feel
yeah, the
in
Romans
touch
did this.
with our ancestors.
Absolutely, man. If the Romans did it, it's good enough for us, right?
Apparently, when in Rome, when in a bathroom stall.
Oh yeah, they apparently found. Speaking of Rome, they apparently recently found evidence that some Neanderthals have been exposed to lead. And
Ooh.
why does it have to do with Romans? Because people believe that the fall of Rome may have been related to all the lead in the pipes, making everybody stupid.
So the idea
Um,
is, from what I recall, is that the Roman civilization, built civilization, some of the firsts, like aqueducts, which is a way to get water from one place to another, like to power a city, not power, but deliver water to a city from a lake or what have you. And they had roads, and they had like forums of governance, and they had piping, which is how the aqueduct system was.
well, the
Is
aqueducts are
that
a little
related
different.
or?
I think the aqueducts are a little different,
Oh,
but
okay. Well, either way, they're known as like peoples who did some of the firsts of the staples of civilization and infrastructure, if I'm not mistaken.
well, I mean,
So,
it was one of the advanced civilizations. Before that, before Rome, the
well, there's
more
also mass scale at which they did it.
yeah, it
Uh,
was a very large civilization, right?
right. So what?
And it was contemporary with like Egypt was in decline by the time of the Roman Empire, if I remember correctly.
So what would happen, from what I understand, is that Romans built a bunch of pipes to carry water or what have you around their cities, and the pipes were made of lead, and they brain deaded themselves.
Yep, kind of like we did with leaded gas.
Oh, you mean like
Uh,
we did with Flint, Michigan? I mean, the next one, all the Michigan water.
let's see, one other
But no,
interesting.
that is actually it's not recent news, but it is science news that I don't remember what year it happened in, but some time ago, humans theoretically did a bunch of activity in the sort of the colonial, I think, period where there was a lot of exploration and things like that.
Mhm.
Or rather, it was the period of exploration to Antarctica, etc., that found this out. That there was just a massive poisoning. What you mentioned about the gas. Could you elaborate on that real quick? Because I find that fascinating, the history. So instead of the future, aka news, it's sort of the history of humans, that we poisoned ourselves with leaded gas.
Oh yeah, well
I
there's
don't think many people know this, and it's just fascinating that actually
yeah.
happened.
What is the name of that? There was like a place that has great little stories on YouTube that we were watching for a while that talked about the whole leaded gas debacle, where basically a guy who he was trying to do an
Was it today I
experiment.
found out, or
Uh, no,
no?
I don't think so. But basically, there was a guy who was trying to do an experiment, and he just kept getting lead in every one of his experiments, and no
And it was
matter
like
where.
experiments on like Antarctic ice, or was it just regular experiments?
No, he was just
Oh, okay.
trying to do experiments in a lab, and it
Oh,
just
okay.
kept getting freaking lead, and it screwing up his experiment. He like just went out of his mind trying to fix
To scrub
the and
this.
it just kept getting adulterated experiments until finally he discovered that you can't get away from it because the lead was being raining down on us everywhere on the planet because of leaded gasoline, and so it was just and that's how we ended up starting to get rid of it because we began to understand exactly how much that could be screwing us over.
Yeah, in case
Uh,
you're wondering why it says unleaded everywhere
okay.
on your gas pumps, that's why, because at one point it was leaded, and what that means is with lead in it. And I'm sure you've heard about lead in like
Maybe it was
now the word's starting to sound weird.
maybe it was 10 ed or something. It may have
Maybe.
been like a 10 ed.
So yeah, you have little boxes that you think of science fiction, right? You have little lead boxes they put kryptonite in or something, where it doesn't affect Superman or some such. But lead actually was in paints and other things as well. That was had to be removed as well because a lot of the artists were going mad, having been in in a lot of contact with the paint. It's really interesting that the way lead affects
Well, mercury
physiology, the way
mercury
it
made
affects
people
psychology.
mad. Does I thought the effects of lead just
Mad
make you
Hatters.
fucking stupid. It's like I don't think that the I know that mercury makes you madder than a hatter, yeah. Which is apparently they used to put mercury in like the brims of hats, so that's why people that's why the whole Mad Hatter thing is a thing because hatters were exposed to mercury and it made them fucking mad. Um, but no, if I could remember, man, it was such a good little. I think it was TED Ed where they do the little like paper cutout animation kind of thing, wasn't it? I don't know, it was good. It was a good little thing. We wish we could find that. But no, so it was yeah, apparently yeah, Neanderthals somehow got exposed to lead. So that's a interesting little tidbit. That's like, well, how on earth did that
Theoretically,
happen?
Neanderthals died out and or were killed by humans and or
Oh,
interbred
wait,
with humans.
yeah, we definitely interbred with them. I know specifically.
I know
Uh,
several myself.
yeah, no, I know I have Neanderthal blood. That's
Oh yeah,
my
that's true.
because the
I know several
yes,
myself.
the it was apparently my parents got genetic testing and stuff. And a large section of North American or not European people have Neanderthal blood, and so there's so yeah we definitely we killed them and we basically outfucked them. They Neanderthals
Boner.
yeah, Neanderthals, because they were larger, would have taken. They had much larger brains. Also, would have taken a lot more. Uh, they were mainly hunters, so they had to eat a lot of animal fats, and then they would
Didn't they
also
have longer, not gestation, but caring for young?
right their sexual maturity
That's the word.
would have been later, and so because of that, we could produce more
Faster.
total units.
More warriors. This is the
Right.
StarCraft, you get more
Exactly.
Marines
We
that,
zerged them
yeah.
basically. They had bigger brains. We zerged them.
Took
Um,
longer for them to evolve their warriors.
yeah. And but we won't get into the whole. There's also something called the Boskop skulls,
Not on
where
this show, but maybe.
but I'll hint at it that there is a collection of skulls where the one of the ways in which we identify the difference between a human brain and a chimpanzee brain, and like one of the major differences, I mean, um, is the size of the prefrontal cortex, which is the executive function, planning, things like that. So as
The things
much
that build civilization, theoretically.
right,
Enable us to build civilization.
the amount larger than a chimpanzee brain that a human brain typically is, the Boskop skulls indicate that their prefrontal cortex was that amount larger than human. So that's an interesting little thing about that. And at some point we need to do a
I mean, it is archaeology related, but,
we need to do a show on the possibility of an ancient advanced civilization and
well,
how it could have.
we have been watching the Atlantis stuff, so maybe we could piggyback off of this archaeology conversation, and for the next Cherry Stem, go
Yeah.
into the what is it,
Hmm?
the desert, the Saharan desert,
Oh yeah, that thing that was neat.
whatever the fuck it's called.
Yeah, that is really cool.
Yeah,
Uh,
and therefore talk about other
and I think a lot.
conspiracy theories.
I think it's very important for people to know that Troy used to be thought of as a mythical city that didn't exist as well until we
That
found it.
Yeah, Troy was the same thing as Atlantis. It was written about by one of the poets, the Greek poets. One of the Eases, Socrates, Aristoteles, some sort of ease. And yeah, he wrote about Troy, and people were like, "Ah, look at this mythical city." And then they found it. They uncovered it, buried. And so the
Yeah.
idea is, if they wrote about one city that was real and then it ended up being real, then if they wrote about Atlantis being real, why would that not be real?
Yeah, and I used to. I don't know why I don't see Graham Hancock's posts anymore. I used to have him on my because he just would constantly show all of these another discovery where civilization is way older than we thought. Oh, look, another discovery that indicates civilization is way older than we thought. Oh, look, all of our stories about where civilization came from, where it started, have been repeatedly proven wrong by archaeological discoveries, especially over the past 15 years or so. Where everything from the Göbekli Tepe, which is one of the most popular ones that people talk about, but there's so many more that kind of show how our ideas of where the cradle of civilization was and how it started up were just somebody's story that they just threw together based on really old information. It's kind of like you if you look into the history of what we used to believe about dinosaurs, it's pretty funny too how much we just kind of like threw things together and put bones together wrong and put whole stories together that were like just complete bullshit.
That is the thing that
It
happened.
became orthodoxy.
Yeah, you had one skeleton that ended up being comprised of like four different dinosaurs that were just
Yeah.
put together, and then
The more famous one is the Brontosaurus that they're thinking. First, they said it's definitely a different skull, and it was like the plesiosaur or something like that. And then now they're saying, well, no, there was a Brontosaur. There's another more recent thing. I don't know. It's kind of funny, but the point is that there's you do have to understand science is done by humans. It's not done by gods. It's not done by some sort of perfect thing. The information itself is actually, you gotta look at it carefully. And a lot of times we make mistakes and we keep trying to fix them. But we're not perfect, but we're damn good at it. Yeah. So did you want to go on to
Yeah.
the pilot wave at this point?
Was that it?
Well, there was all the ones I thought were pretty interesting. There's not a whole lot more that I could pull out of my ass here.
It's okay.
So,
It's just the what we talked about so far was a little bit was conversation could not be loaded. What? My email is being silly. Yeah, the we had the sort of a bit of a physics and a bit of archaeology, and if we wanted to go off of here for the next show, we could, as if we have viewers who listen to the shows one after the other, they will at least have a little bit of a primer about archaeology and the alternative interpretations of that as well. So that's interesting that we actually have the two pursuits or the two sciences in which we do not buy in or uphold the conventional explanation of things because there's so much overwhelming evidence to the contrary is physics and archaeology.
yeah, and one of the biggest problems is that
Our past and our future, essentially.
the strength of being a very exact person also gives you the weakness of not being able to pull together larger pictures. And so you have people who are big picture type of people who also just their problem is they're not good at making sure the details fit. And so you have these two major mental types that you kind of need to be able to switch back and forth between. Otherwise, you're really missing out on a huge section of the way that you examine the data. And so there's people who either they're looking at the big picture and so they're missing out on how the details prove that the big picture is wrong, or they're looking at the details and they can't put together the way that the larger picture shows that those details are that they're seeing that they're confused about what those details mean. And so that's your main problems that you run into in any kind of development of knowledge systems. Whenever we're doing science, we kind of tend to run into that a lot.
Well, I would actually also like to talk about AI news at some point. But for instance, the sixth biggest extinction is, animal extinction is underway. Has been the latest research, and this was just published in the Proceedings of the National Academy of Sciences, so PNAS. Penis on October 15th, 2018. So like super extra recent. And the sort of the blurb here is the biodiversity is more than the number of species on Earth. It is also the amount of unique evolutionary history in the tree of life. We find that losses of this phylogenetic diversity are disproportionately large in mammals compared with the number of species that have recently gone extinct. The loss of phylogenetic diversity can only be restored with time as lineages evolve and create new evolutionary history. Without coordinated conservation, it will likely take millions of years for mammals to naturally recover from the biodiversity losses that are predicted to endure over the next 50 years. However, by prioritizing phylogenetic diversity in conservation, we could potentially save billions of years of unique evolutionary history and the important ecological functions they may represent. So to break that down is essentially we are seeing a loss of the variety of the minute or small, or maybe not so small, but all sorts of varied minor and or major differences between species in mammals. So, you have like the flying squirrels and you have the ground squirrels and you have the, 10,000 squirrels. And we are seeing a loss in the variety of that. That's what phylogenetic diversity means, if I'm, understanding that correctly. And we are seeing essentially the way that evolution happened in the unique circumstances that surrounded our development as a species, and every species that surrounds us. We all co-developed, and that created unique pressures and interactions that caused
complex dependencies and systems that are dependent upon each other, interdependent. And when you start breaking down
coevolution,
right,
yeah.
and now we're back to what I was just talking about a moment ago, not being able to see the big picture. It's like, well, why do we need all those animals for? Well, you're not understanding exactly how reliant you are upon them. I mean, we can talk
And
about
also
bees, or we can
it
talk,
is a unique,
and that's just not a good enough. You can tell a person who doesn't get the big picture very well. It's like, hey, well, what, you understand that we're relying upon the bees, and they'll still just focus on, well, that's just the bees. And there's always this, like, they don't understand interdependency very well. Why are you?
oh, you're like the kitty
It's fine.
scratching.
Don't worry. Don't worry. It's good.
Sorry. I spurred out for
I
a
noticed.
second. but yeah, essentially that's sort of the boils down to that. The what you're saying is that you have that's just a bees, except it's not, because they pollinate things that other things live off of, and things live off of that, and it's a complex chain of interactions. And so and
Well, they
it's not
keep
just that.
failing. Here's the thing. Here is when it comes to, there's a specific mindset that is a forward-looking, forward-moving mindset, and that is they fail regression analysis. And that is, okay, anytime you ask the question, why does this do that? Then you end up locked in this going backwards chain. And anytime you start to try to look through this chain, it branches immediately to well, why? Because of this, and this. Then you have to say why for every one of those other little things. And so it branches exponentially. And so one of the ways the human brain has basically, it's a way to move forward, is that you arbitrarily stop your regression analysis at just picking any particular one. So you just pick one reason and say that's the reason, even though it's not anywhere representative of reality. And then you move forward with the tools that you have, and that's useful for a primate, and that's useful for a more simple brain, but it's not useful for the rulers of the planet. Now that we are the rulers and managers of the planet, not being able to do regression analysis, not being able to look at it without instantly halting and saying, "Oh, I'm done," whenever looking at the way that things work together, it's a huge problem. And that's what you'll find, that some of the most powerful brains, man, something that spit went down the wrong way. Some of the most powerful brains, and the best way to do things, you can't get lost in analysis paralysis. If you want to make something go, you want to make something work, you gotta keep moving forward. You don't look back. But that's also a good way to just run straight off a cliff, because you're not looking back, and you're not looking at and trying to figure out where the mistakes were made. You're not looking back and analyzing all the little points, and that is a huge process that can end up being fruitless in certain cases. You're looking for exceptions because you've been following the rule, and so searching out those exceptions and those tiny faults and finding all those things, that's not our forte as a scientific. And when you're talking about people who have scientific minds, that is not their forte at all. Any kind of going backwards, fuck no. We want nothing to do with going backwards.
Mm-hmm.
We're moving forward, buddy. I'm believing in whatever systems that have been working generally. I ain't worried about the exceptions. I'm dealing with the rule, and we're going forward. And that's and you know, even as a programmer, it's like I ran into that myself. I started trying to do, you know, regression analysis on every single tool that I was using, and it does not work. You will not get a single program written unless you just rely on what was given to you and move forward. That function call, I don't need to know how it addresses the hardware. I don't need to know how it addresses how it prints pixels to the screen. I don't need to know any of that. I need to make the program that I was assigned to make. And to do that, I just make the fucking function call and worry about my program. I don't worry about everybody else's program. And the thing is, my program does occasionally end up failing because of that. But I don't worry about those exceptions. I worry about the rule. And so there's a basic mindset of progress that is all about a habit of not doing regression analysis. Mm-hmm. And so that's why we end up having these people who do say, oh, that's different, and they don't see the ways that all of these things are interlocked. These interdependent systems are very difficult for them to conceive of and understand well, because they are not in a mindset that regularly does this sort of regression analysis, which is basically looking at fucking infinity and trying to sort through stuff that basically you have to spend a tremendous amount of time, and sometimes almost fruitless time, on. And so
I'm sure some viewers can feel that feel where,
yeah,
you know, you do that, and yeah, it totally makes sense that you would have a system for cutting that off.
Right, and it's a natural system. It makes perfect sense as an efficient design for a human brain.
Right. However, we have entered complexity with how we've pushed our civilization, and where we find ourselves in the current day it requires more nuance than that. And of course, it isn't just keystone species that etc. And interlinked species and hierarchies that depend on each other, interdependent hierarchies that we also depend on. So it isn't just our lives that potentially are affected by this, and of course the future generations' lives. But I find it interesting that essentially this is the link to the archaeology news, is that we are, well, this event, this thing, is erasing our unique history, in a sense that we all co-developed on this planet in a specific way, that all the push and pull against each other, and we grew up together, and like a bunch of trees, you know, that are tightly clumped, they affect each other's growth and access to sun and things like that. And so it is a unique shape. It is a unique thing shaped by the interactions of the active participants. And so it's almost like a snapshot. It kind of reminds me of our holonomic theory episode somehow, but it's like a snapshot of I don't know,
well,
us.
Here's the best example is where, like,
us as an organism.
People talk about the butterfly effect, and they tell that story about how the butterfly flaps its wing and it does this and it does that, and eventually, you know, somebody has a car crash and dies, and you know, and it's all because of a butterfly flapping its wing. But the thing is, it's not just because of the butterfly flapping its wing. It's because of billions of other chains just like that chain we can go through. We like to think about that one chain of event. Matter of fact, I remember there was a series called Connections. I think I've brought it up before, perhaps on another broadcast, where they go through and say this led to this, led to this, led to this, and there's this linear chain of events that we can put our finger on. But the problem is that there is something more than linear processes. There are processes which are not linear in the way that they work. They are mutually dependent upon one another, and you can't put them in a hierarchy that fits in that linear chain of events. Each one of them is like a river, and that is, a river is not a river without the water and the riverbed, and it's only the combination of the two that makes the river. Well, there's some phenomena that are a combination. In other words, the phenomena itself, the event itself, is a combination of things and cannot be. There is no linear hierarchy where this does that kind of thing. And so understanding that has been a kind of a crucial advancement that's been going on over the past, you know, once again, about the past 15 years since the millennium. People understanding complexity in physics, complexity in science itself, having this understanding of how this basically it's not even non-linear. It's a concurrency to the way, concurrency to things that might otherwise be conceived of as hierarchical. In other words, they are not hierarchical. They're where there are multiple things causing something, and so that's kind of the difficulty we've been attempting to overcome, in science itself. That's what's leading towards advancements in AI. That's what's leading towards understanding biology better. Instead of trying to put together these linear chains in the way that biology works, we're starting to understand, effects like emergence, and the emergence is this kind of convergence of various simultaneous things creating something else. And there isn't a linear, chain like that. And so that's kind of that's important to, for moving forward.
Yeah. And yeah, it's like not a big deal, obviously, biodiversity, who cares? But at the same time, it is sort of a, unique history
No, it's not.
and
It's
our
not a
current.
who cares. It's like all of the various things that sustain us are all part of a single thing, and so each one of them takes away from the way that we live today in a way that we can't quite understand, because there's so many different tiny dependencies that are, they're all interlocked with each other, and so losing each one of those species in aggregate, the loss of lots of species become a very large effect that we won't really understand very well for a while, because it's too complex. It's just like, okay, a good example is chaotic determinism. We can only figure out, how a system which is has complexity in it will unfold using probability. We simply don't have. There's no way, because there's too many different things. There's no way to predict the outcome, even though it's completely deterministic and mechanical. You have to still use probability to guess at the way that the outcome will happen. Well, the same thing is true when we're trying to think about the number of ways in which all of these different species impact us. It's too complex. All of the various effects aggregate and add to each other in these ways that are so transformed over time and over their combination between each other, that there's no way for us to predict exactly how massive and in exactly what ways it is impacting us. And then, we only see them kind of after the fact, and sometimes we won't even really recognize them after the fact, why this system is falling apart or this system over here, because they'll seem completely unrelated when they are factually related.
Cool. Yeah, it's hard to follow up sometimes.
Let's follow up on that. So, pilot wave.
So, exactly. So, changing the trajectory completely 180 degrees. Well, actually, not exactly, because we're still talking about. I mean, I suppose it's sort of related.
Yeah, we're talking about chaotic determinism. That's definitely part of pilot wave.
Yep, yep. And if you were here last time or have caught up on your CherrySTEM 28, you would have gotten a bit of a primer about pilot wave, etc., and the way we think of it and conceive of it. And you may, if you haven't though, you may already know about pilot wave. If you don't, a quick way to sum it up would be it is essentially a theory based on silicon drop experiments by Coudet et al.
Well, it
That
comes from earlier. That's
well,
new stuff.
sure, okay, so it has a lot of runway, but essentially you can find out about it by looking at oil drop experiments that sort of give you an idea of how a particle and a wave duality can actually be explained.
Let me try to
Sure,
help
go
out a
ahead.
little bit here.
Yes, please.
So, okay, there's alternative
I can do it.
interpretations. No, I
Go ahead.
understand. I'm just gonna give you some help. Sometimes when you left it with something, you gotta start pulling pieces together when you're not ready. So there are various interpretations of quantum mechanics. Now, what you have to understand is, so we have this math that matches our experiments, but we don't necessarily know what that math really means. Okay, so how do we get there where we have math disconnected from what the math represents? And it happens because sometimes we're just sort of we're playing with various ideas, and ones that worked in other ways, and then we take the pieces of math that worked for other things and then apply them in a novel way, and sometimes it ends up matching experiment. And then we don't necessarily understand because of the abstraction layer of what the math is doing. Like, for instance, when I'm going back to the programmer analogy, I'm using math technically anytime I'm programming, but if I were to be exposed to just the calculations and the numbers that are being moved around in the computer in a program that I wrote, I would have no fucking clue what I'm looking at. It's because of that there is this connection between the layer at which something is comprehensible, and then the way that the numbers move around in the functions and in all of the math that's going on make it where it can sometimes be difficult to keep your eye on the ball. So, pilot wave theory, many worlds interpretation, and the Copenhagen interpretation are all competing interpretations of quantum mechanics. But now the math changes very, very little, if at all, and only in ways that are very, very subtle. In other words, it's only through like extensions. If you extend it to this specific domain and do it in this one particular way, okay, there it will come out differently. But the basics, for instance, the Schrodinger equation is probably the best example we could use here, and that is, so Erwin Schrodinger was looking at De Broglie's work with and De Broglie was attempting to use Einstein's work for a theory of how light particles, and which he called corpuscles, would work. And what he was doing was deciding that waves adding together, through interference, might create these packets of energy, and so he tried to use special relativity in a very novel way that today, if you started talking in the way that De Broglie did in his paper on this, it'd be like, no, you're completely misunderstanding relativity theory. You got it all wrong. The way he used it would not match most people's idea of how relativity works today. But so he used that for a way of looking at the way that waves interfere, and this was De Broglie, and one of the interpretations of quantum mechanics, pilot wave, is also called De Broglie-Bohm. But when he created this paper, then Schrodinger, who he's the one who originated the wave equation that shows us all of the places that we would find electrons, for instance, in a hydrogen atom, and all of that, which is, it's the very central, probably the best, most central part of quantum mechanics would be the Schrodinger's wave equation. Mm-hmm. And what he pointed out numerous times is that there's a difference between a shaky or out of focus picture and taking a snapshot of clouds and fog banks. That's his quote. I just quoted him. And so the point is that your math can represent, it can be separate from what's real, and specifically when things are very complex, we have to use probability to grasp something that has too many different factors that can alter it. The only way you can do it is with probability. That's called chaotic determinism. It can be deterministic, completely, one thing does another, but there's too many contributing factors simultaneously for there to be any possibility, and especially at the smallest level this occurs, for there to be any possibility for us to really predict it. Now, we have this happen at large levels too, in weather systems. Weather systems are chaotically determinate, and that is that you can't just predict the way that the weather is going to happen, because there's too many factors. It's literally impossible. So all you can do is probability. Now, when you look at the math, if all you had was the math and you couldn't really watch the weather happen, you might believe that at the very lowest level, what's occurring is probabilities. And that's what happens in the Copenhagen interpretation. We started to believe that based on Schrodinger's probabilistic equation, in other words, he determined that there are probabilities that you would find a particle in a given location. They then interpreted that to mean that at the very lowest level of reality, it's all probability. In my opinion, that's a complete asinine absurdity, because there's no such thing as probability. It's just a mental construct. But that's basically, one of the most core tenets of Copenhagen interpretation. So it's a different interpretation. Then there's the many worlds interpretation, and that is that instead of reality being, this probability at the basic level, what happens is reality just splits into infinite worlds
every millisecond.
All the different possibilities that Schrodinger equation represents, because that's what it does. It represents all these possible locations for our particle in many worlds. All of them are real. They all end up just fucking happening. And so that's that's kind of the basis of many worlds. In Pilot Wave, it says, no, both you motherfuckers are wrong. It is something really happening there, and it's just the information incoming is so complex that it's our tool. We're just using our tool, and we think that the tool is reality. We're confusing the two. There's a difference. The tool is not reality. It's just the best way for us to represent reality, and that's what Schrodinger was trying to tell people. And that's what the whole when you've heard of Schrodinger's cat, it was him trying to tell people, no, you're fucking stupid. If we couple, this probability at the lowest level, and allow us to see that's like, okay, well, that's going to lead to this, which is going to lead to this, which is going to lead to a cat that is both simultaneously dead and alive. And he was literally poking fun at people and telling them they were fucking stupid.
Right. It's actually a satire. It's actually a Poe.
Right. And then, it's not even that. He was saying this is fucking absurd.
Right,
and it's
right.
like
He wasn't even trying to pretend to be one of them.
He wasn't.
It's not a Poe, but
and then for years afterwards, they used it as an example of this magical property of reality. They literally used his example of saying, "Hey, you people are fucking stupid. My equation doesn't mean that." And they took that as
it'd be as ridiculous as saying X. Wow, this X thing is so profound.
It's so profound, man.
From the man who created the.
Whoa, dude. No.
It's like my hands can touch anything but themselves. Whoa.
So that's what So he was trying to point out, is like there's a difference between a shaky or out of focus lens and pictures of clouds and fog banks, and so Pilot Wave. So the story here,
right.
why we had this
right?
Why are we talking about Pilot Wave? Pilot Wave is also called de Broglie-Bohm theory. And why is it the least talked about? It's the least talked about for a number of reasons that just have to do with social mechanics. It has nothing to fucking do with science. It has to do with people, as usual. The biggest problem in science is people. And so you'll find that there are tons of where people always think it's like, you have a lack of faith in science. No, it's my lack of faith in people. It's like, how could you believe that this is wrong? You're crazy for believing that this is wrong. I'm not saying it's wrong in the way that you think I'm saying it's wrong. You just don't understand the difference between people's interpretations and reality. You're confusing things here. So there are multiple interpretations.
Well, there's always, if any scientist knows that you have data sets and then you have how you interpret them.
Right.
There's always two layers of information.
Oh, I know. That's what's great about, like there's these various studies
where at the very least there's two layers.
They can reinterpret their data to mean just about anything.
Yeah.
And so that's why you have to be able to. So how do you find truth is an important thing. You have to look at it from a lot of different perspectives. You have to see the way that these systems unfold and these systems unfold and these systems unfold and converge them. How do they all interact with each other? And that's how you end up finding whether or not something is more or less truthful, not by the number of people or the special hat and robe that they wear or any of those things. It has to be the way.
The special white lab coat? That's
not.
Oh,
yeah. I was talking about the other kinds of robes and books that they hold and special pointy hats, and it's the same thing. So
wizards.
Wizards, religious people. One way or another, there's the special class of people who hold the true. Really truth.
Sometimes they even bind it to their heads.
Yes, exactly. They're special, and they're the. How dare you doubt them?
Their mommy said they're special. I mean, God said they're special.
somebody, an
Somebody
institution, some institution
said they're
of
special.
authority said that they were special and true.
Yes.
Um, so here's the thing. The reason why that was, not popular, there are certain things that were difficult that we did not yet, unlike chaos theory was not mature until what, like the 80s or something. Fuck, I don't know. It's the idea of chaotic determinism, this idea of complexity and complex effects. I mean, uh, all of these things are fairly new, and they weren't really around at the time that quantum mechanics was um, really starting to develop. And the truth of the matter is, the math that we use to work with these systems works because math is kind of like you take this part and try to put it with that part, and it's like gears. You put three gears together, they're not going to fucking work at all, period. Okay, it's like they'll lock together. And the same thing is true with math. As you start to develop, you can sit there and kind of smash pieces of math together, and either they will work or they will not work. And so you can kind of create machines in that way. And so math is like a machine that you can only make it work in certain ways. So there's a level of truth to it. In other words, there is a level of development you could have without understanding what the fuck you were doing. You don't have to know, you don't have to understand. That's why you can shut up and calculate, because the calculations, if they're right at this one place, will end up being right at another, and therefore you will be able to predict based on this set of math. You'll be able to predict something else, and you can without understanding what you're doing, you can still create. You can still use the tools to create valuable things. And it's just like higher level programming languages. You don't have to understand anything about the hardware. It can be a complete magical set of nonsense to you. You can believe in it completely superstitiously as a programmer. You can be trained how to use a development environment and make programs without having the faintest fucking clue what's going on underneath the surface. And so the same thing is true of various systems in science, is that you can continue to develop to a certain point. You can still make advancements without, having any understanding of the fundamentals underneath that you're using. And so that's why we can have these things in science that, you use the machine of math, and math can only keep coming out the same way. It's, even when you change it around a little bit, there's still only a certain way that gears will work together, and without them conflicting with each other. So in now we talked about all this to talk about this new thing where they came out and said, oh well, pilot wave.
It was literally, as we mentioned in the beginning here, it was literally the day after our broadcast on the fact that they found flaws with multiverse theories and a bunch of other things, and how there's model crisis, and essentially pilot wave can cure all that. And it was a day or two later. It was within 48 hours, though. It was pretty weird.
Yeah, and whenever you start getting into the belief systems that crop up around Copenhagen, for instance, it really does come down to, if they, for the longest time, part of Copenhagen was this kind of a spiritual aspect to it, that it's our observation that creates a universe. And now today, most people say, no, that's what those kooks tell you. Observation is any kind of interaction. It doesn't have to be consciousness. Well, except the problem with that is that anything then becomes an observer by extension. And so everything in the universe ends up collapsed. You can't have an uncollapsed wave function, because everything ends up being an interaction, which ends up being an observation if it does not require consciousness. So the truth of the matter is, no, you really do need the consciousness causing collapse if you still adhere to Copenhagen interpretation and an actual collapse of the wave function. So that magical, it's baked in. You can't remove it as much as you'd like to. That magic is baked into Copenhagen. With many worlds, there's not a whole lot you can do, to about. I can't disprove that there aren't fairies, and I can't disprove that there aren't billions of worlds being created every second. But it's just it's one of those things that kind of should be removed by Occam's razor, especially when we have de Broglie pilot wave theory as an alternative that completely makes perfect sense in a variety of ways, and we have this macro level version of it. And that's what's important here. Is it's called the Coudet experiments, the Silicon Walker experiments. There's a couple of different names for it, where basically what we see is these behaviors that were always so weird in quantum mechanics. There's all this weirdness. It's like instantaneous action in the distance, and it's a wave and a particle at the same time, but it's not the way that you think it's a wave and a particle. And whatever you say, it's always going to be something more magical and mystical than that. All of those things, those come from Copenhagen's dominance. Copenhagen has been a dominant interpretation, but de Broglie-Bohm.
So it's a Copenhagen syndrome?
Yeah. De Broglie-Bohm has been around, since the beginning. And even, here's the thing, one of my favorite parts of this whole debacle is that the Bell tests, this is something that's called, that people constantly talk about, Bell inequalities, that show that, that the reality has to be super weird and special magic. And Bell himself talks about how, why are people still doing these impossibility proofs? Why, how is it that nobody talks about the de Broglie-Bohm interpretation? Why wasn't I told about it earlier? And when basically all of this indeterminacy is a theoretical choice, and this is what Bell himself says, and he's the one who was, and this is after all of the Bell inequalities, all of that, he understood that it doesn't apply, that it's not necessary. It's a bunch of self-delusion to uphold magical ideas about reality, and a lot of it is actually tied to us needing to have the concept of free will. And because everybody fucking hates, and down to the depths of their soul, they scream at the idea of determinism.
Even people who believe that God made them the specific way that they are as a vessel.
Even when they believe in predetermination and stuff,
and that God will send them to hell or to heaven. Depends on what he wants to do. That's written in the Bible, right? He says that
even when they believe in predetermination, they still believe in free will.
Exactly.
They're of course, a fundamental conflict.
Yes, they're that unwilling to give in to the determinism.
So in my opinion, a lot of the problems in physics actually do have to do with people who are the humans having religious beliefs and having special, these certain beliefs that they instead of allowing their understanding of God to be based upon reality, they instead make their understanding of reality based upon the beliefs given to them beforehand about God. But anyway, I'm not going to get into the religion part of it because I believe that religion is compatible with this specific theory of physics.
Well, there's difference between phenomena that are not currently physically explained and religiosity, which is
religious behavior,
dogmatism,
dogmatic behavior is something completely separate from religion,
quote unquote, a capital R religion.
Right, exactly. And so I'm not.
The Venn diagrams frequently overlap, but they're not.
Right. I am not against religion. As a matter of fact, I believe that once we start to understand physics better, we'll actually understand aspects of spirituality and things like that. But we have to give up magical beliefs and things like that first and accept whatever reality says it is, and by really testing it and instead of believing magic first off and saying no, there's got to be magic, I'm magic inside me, I'm magic, instead of doing that first, let's first say, okay, what is really happening in reality, and does it work, does it
Well, that really goes along. That's the same issue essentially that I would say it plagues the thing that I'm, involved in. So like physics is your thing, and like psychology or whatever is my thing. If we're gonna crudely divide them like that, and spheres of most interest and time spent on and in these fields, and that's the same issue we have with sexuality and psychology, where people refuse to look at look at the reality of themselves. Exactly. And instead
always want the self-delusion first.
Right.
First, if it doesn't fit my self-delusion, fuck whatever that information is.
Self-delusion as in like this grand idea of what we are or what we do or what, and that goes back to our false beliefs on physics and archaeology
and everything. It's always
it's always that.
And I think you could sum it up in saying that a mother feeding its child can be seen as a beautiful, self-sacrificing love, or it can be seen as maximization of genes and a completely selfish action. And the truth of the matter is, it's both. And you can choose to focus on one or the other, and I believe that's up to you. And I think it's healthier to focus on the more beautiful version of looking at reality, but we can't then throw away the uglier, more real version of reality that's really there as well. There's it's still there.
Mm-hmm.
It's maybe you don't want to focus on that, but we have to accept reality as it comes to us,
Right.
without continually throwing our primitive desires and shit like that onto it. And so we always have to be that's supposedly what science is continually trying to throw away all the bullshit, primitive, emotional stuff that we try to filter things through, and constantly to be looking for those and looking for where are all the pitfalls of what I want. And one of the ways and unfortunately, one of the ways that becomes self-defeating is that at a certain point then it's like, well, you're just wanting things to make sense, and the world doesn't have to make sense to you, buddy. It can be all magical and chaotic and confused and self-conflicting if it wants.
Mm-hmm.
Okay, then we have to throw away logic itself. So we either have to believe that there is some system of the world. I'm not the center of the universe. The universe does actually have rules and doesn't
Mm-hmm.
constantly conflict with itself and basically be a big ball of conflicting shit.
Mm-hmm.
You can because if it is that, then there's no reason for you to ever care about anything.
Right.
You are the
It's
center of
just,
the universe. You're
and it's all
floating around,
chaos
and
and
it's all chaos. It's all just magic, and it's all just your perception, man. Um, but if it
that's
isn't
just
that, then,
like
then
your opinion, man.
right, then you have to kind of
Postmodernism, essentially.
then the idea that, oh, well, you just don't like it because it's counterintuitive, or that's the same religious argument that God's behind you. And so I'm not buying into the either one of those. Sure, let's say that there are things that are beyond us currently, but saying that reality is completely outside of our grasp and all of that's just a self-defeating pile of shit that people use to try to just win the argument whenever they want to have their feels. And so, all that aside, we took a huge tangent there. That was fun. I enjoyed the visit to that tangent. That was great. But let's go back to where we were supposed to be. So, in pilot wave theory, then you have the Walker experiments that show all of the magical weirdness in that we tried to accept
Mm-hmm.
as part of quantum mechanics can be explained in a completely new light. All the things like one of the things that Feynman says is that it's absolutely impossible for it to be the way that it is. Speaking of the dual slit experiment,
Mm-hmm.
it doesn't make sense in the macro world at all whatsoever. There's nothing that could ever make sense about this. Now we have something that makes sense. And that's what you need to understand, is that they didn't have some of the greats from back then. They did not have an example like we do now with the pilot with the Coude Walker experiments. And it shows, first off, the two slit experiment. It shows not, but here's the thing. It's not just that. And that is what we're getting to in about this news story, is that there has been a failure to replicate by two different labs. They
Mm-hmm.
have failed to replicate Coude's original experiment, specifically with the two slits. And one of those labs is a lab who basically, if it were to be replicated, his family name would be besmirched, because the Copenhagen interpretation is kind of Bohr's baby, Niels Bohr.
Uh-huh.
And one of the labs who somehow failed to replicate it is the son of Niels Bohr.
Oh.
And I'm wondering if there might be a connection between these two labs and this news story all coming out all at once together. I'm not saying that they're biased.
And we're not saying that there are coordinated campaigns to either silence or censor or in other ways remove mention of upsetting people's or ideas that we've seen recently on the internet. Cough, cough, Twitter, Facebook, cough, cough.
But anyway, but here's the thing. So the contention is that, oh, now it's failed to be replicated. That's it. We can throw it away. We don't need to talk about this new pilot wave thing that's been coming and showing that all of our magical beliefs are shit. Our magical beliefs are real because they failed to replicate this one. Well, first off, there was only a failure to replicate one aspect. Okay, one small fucking aspect of the way in which walkers replicate lots and lots and lots of behaviors of quantum particles. But the thing is, we've got a theory, we've got behaviors that have been fooling people for what, 70 freaking years now, and we've just finally got some experiments that replicate all of those various behaviors, including the dual slit experiment. And so of course it is a very complex set of experimental setups that are very difficult, and so just failing to replicate them certainly does not, failing to replicate one single aspect of it certainly does not in any way prove that pilot wave is not a valuable direction to go. It's absurd, but it was heralded as like, that's it. I forget what the name of the article was. Man, I gotta find the article. Here it is. Famous experiment dooms pilot wave alternative to quantum weirdness. Quantum magazine.
Well, actually, I also received a notification about this thing.
So here's the thing. I actually reached out to.
Hold on, I have it too. I have I don't know if you guys experience this, but having a Google phone and Android, they're pushing all of Google's products in your face. And one of the things that they do is they push recent news stories from Google search, essentially, into your phone. So whenever you want to search anything on the internet on an Android, you have to go to an area where they are force feeding you stories that you can select based on your interests, but still force feeding you recent news stories. And this just exploded onto my thing with pilot wave theory, which I guess it's because I titled a YouTube video that. That's how they knew. But I got famous experiment dooms pilot wave alternative to quantum weirdness. Quantum magazine 20 hours ago.
They love their
It was
magic.
Everywhere.
They'll never let go of their magic.
So,
never.
Both of us independently got this shoved in our faces.
Right.
Within
so it's like
a few hours.
It's like, oh yeah, here's the sub thing. Failed to reproduce the results of quantum double slit experiment, crushing a century-old dream that there exists a single concrete reality.
So the fact that says 20 hours ago, that's our timestamp for how long after our show it was. By the way.
Interesting.
Because that's when I saw it, after you already brought it up to me, by the way. So maybe even less than 20 hours. And I screenshotted
fucking bullshit. I mean, this is like some of the worst of the pop science bullshit. To say it dooms it is so fucking ridiculous, because first they did these experiments and lots of others, and if you want to go, it's called quantum hydrodynamic analogs, or hydrodynamic quantum analogs. I'm not sure which one, but John Bush at MIT is the primary experimentalist, and he's going to have a review paper coming out. I reached out to him, and he's I love talking to scientists who are very straight laced, because they're always very how do I say it? They put their words very carefully and very reserved. And he was like, yes, many of us in the field were very disappointed with the verbiage used in that article.
He's very written many science papers.
Exactly. It's like they're very serious. They're not like me.
No.
So it was great, because reaching out to him about it, basically he's gonna fucking destroy this shit come January, because he's got a review article coming out. But you can go to his website, and there's just so many different experiments, and one of the main ones is just looking at how the motion of a walker, how it evolves in a cavity, shows that same sort of complex behavior. And that is what is at play here. Just because they didn't get the dual slit experiment to work exactly the same, it doesn't mean that, first off, we've got Coudet had tons of videos of it working. I mean, you can watch it fucking happen.
Yeah.
And it just because
we have watched it happen.
Just because they suck at setting up the experiment doesn't mean shit. Is what it means. It doesn't mean shit. So when it comes down to it, basically they're trying to, once again, because there's such a pull for but for people who've taken on a belief system to defend their faith. And so there is, and especially whenever it's magical and nonsensical, people fucking love magic. They love it. As a child, I remember loving magic. Fuck, anybody who gets into science very deeply, becomes fascinated with physics, I'd say 95% of them wanted to be a fucking wizard, okay? Mm-hmm. That's what it comes down to. You wanted to be a wizard, you wanted to find the magic. That's what it was. But the truth, when you start running into the hard truth that there just isn't any goddamn magic, that's hard. That's a hard pill to swallow. Mm-hmm. That's very disappointing. And so I think that basically you have just tons of people who, whenever they find anything that leads to the conclusion that the world's magical, they just jump onto it. Mm-hmm. They love it. They want it really fucking bad. And unfortunately, it's like, man, how do I provide an alternative for all the people who want magic?
Right.
You know,
but don't want religion.
But you know, oh my God, it's so frustrating sometimes, because here you have a deterministic system that works. It works in theory. It works via math. It works in an example. And it completely annihilates any need for all of this crazy shit, and it does all of the same things. But then you have articles like this. The moment one guy who has very good reason, okay, there was another lab. It was two labs. I'm focusing on the fact that it was one. It was the guy. But come on, one of them was literally, it's his father's fucking legacy that this experiment destroys, and somehow he can't reproduce the results of one particular aspect of it, and we've got an article that in Quantum Magazine that's going to him and talking to him about how this just absolutely destroys Pilot.
Are you kidding?
Dooms it.
Are you serious?
No, I'm not kidding you. It's that bad.
That's bad.
It's that bad.
That is bad, fam. That's really bad.
It's like, his grandson. Excuse me.
Oh,
so
well.
But either way, I mean, it's the family fucking legacy that this destroys, basically. Family. And so, and somehow he couldn't get it to work. I don't know how.
So weird.
So yeah, and some of their critiques are just such nonsense. So I mean, let's talk about the real critique of it. Okay, let's talk about some real critiques, and that is, okay, it is in 2 dimensions, so it's bouncing on the surface. Mm-hmm. So when we're talking about this as an analogy to how quantum physics works, part of the problem is that it is 2-dimensional. So there are certain things that it does that will not be able to show us a very good picture of how it'll work in 3 dimensions. So so the pulsations that happen as a walker bounces on top of a surface do create a system that looks 3-dimensional because it's moving up and down in 3 dimensions. There is a lack because most of the information is stored in the 2 dimensions. There's a difficulty there of translating it between this 2-dimensional kind of system and a 3-dimensional system. So there are some differences in the analogy. Let's go ahead and talk about that. That is true. But we do 2-dimensional experiments, like for instance in plasma physics, looking at 2-dimensional plasmas and the vortices in 2-dimensional plasmas is extremely useful. It is sometimes you do have to figure out the way that then fits into 3-dimensional physics, and there are some difficulties there, but that does not in any way limit the value and use of the 2-dimensional pictures that we develop. the analogy is extremely useful. You just simply know that there are limitations to the way that it applies. But this does not in any way limit the fact that this two-dimensional system exhibits behaviors that do match quantum physics and give us a way by which we can then take de Broglie-Bohm theory and the math that de Broglie-Bohm, which basically, okay, so de Broglie is the one who originally came up with the wave equations that were the first prototypes for Schrodinger to create the wave equation of quantum mechanics. And then David Bohm took that and said, okay, well, first off, de Broglie's theory was also looked at by Madelung, who was looking at casting quantum mechanics in hydrodynamic form initially. And so that is, there is a hydrodynamic, meaning that there is a fluid dynamics version of quantum mechanics where you can use fluid dynamics to represent the particles in quantum mechanics, and so instead of it being particles, it actually works based on some much older physics that spawned all of modern physics, which is, hydrodynamics actually is what spawned all of modern physics, and I won't get into that, but
this time.
So David Bohm basically took that and brought it back up and showed how it fit in a more modern context for David Bohm. But the thing is that there's still some lack of connection between the mathematics and the physicality of, keeping your eye on the ball. What does the math actually tell you that is physically occurring in the system? I mean, we have these ideas that have to do with probability. We have these ideas of waves adding together, but what does it physically look like is a difficulty whenever you've used mathematical tools to create something that will have these certain outcomes. And so there's different ways in which you can apply it as well. And some of the trajectories, for instance, that they use whenever they're looking at Bohmian trajectories, some of them are a little too deterministic, and they don't have some of the instabilities that you have in quantum systems. In other words, there's this random noise that's kind of in the background of the quantum vacuum, and so you have to be able to put some of that into the way that these trajectories play out. And so there's all these different little subtleties that once we have these Walker experiments, we then have an analogy that then clarifies. And that's what the Walker experiments, that's why they're so important, is it clarifies, it allows us to keep our eye on the ball and clarifies what it is that's occurring and how it is that it's occurring. And so there have been developments by some authors at Cambridge. There was a knot theorist and who worked with some of the other physicists there to develop something that's called like a sonon, is his theory of the way that particles work. But here's the thing that a lot of people don't get, and that is, whenever we talk about particles in particle physics, it's a point particle, which means it has no dimensions. It's literally a point in space. It doesn't have, it's one dimensional, not two dimensional, not three dimensional, it's one dimensional. And so a lot of times when they're talking about particles, people think of that in like everyday terms. And so whenever they think about particle physics, they think about like real, physical things. Mm-hmm. But in fact, they're point particles a lot of the time. And so they don't even have a physicality to them that it's abstractions. There are all these tools that are abstractions, and understanding that a particle could actually be representative of, different aspects of the particle, and the particle itself could actually be representative of fluid motions like vortexes and things like that. Being able to understand that translation is very difficult, I've noticed, for people, which is why I try to bring up phonons all the fucking time. Right. I constantly bring them back up
all the time
because it's important to retell this story. Right. And that is, a phonon is a quantum mechanical treatment of mechanical waves. So there's no such thing as physically extant phonons. They don't exist in reality. But we can count them, we can use their behaviors, and we can use quantum mechanics to predict the way that these packets of wave energy in a crystalline lattice will move around, and it is useful. It's actually useful in laser physics, for instance. And but what it is there's no such thing as a phonon, but we can use it as a tool. And our mathematics, we need to be able to treat certain things. It's like, how would you figure out how many gallons, how much chlorine you want to put in your pool if you didn't think of how many gallons of water there was? But there's no such thing as a fucking gallon. It doesn't really exist. You can't, you can hold a gallon jug, but it's a measurement. It's kind of arbitrary. Now, it just so happens that our measurement, the amount of a particle is tied to something. And so that's why they seem more real, that the particles themselves, they're not continuous, like, that's why we don't think of them as continuous. And a lot of these particles, and then you can confuse massive particles from energetic particles. It's like you whenever you're thinking of quantum.
Too many particles, man.
Oh,
That's the weird thing about quantum too, is that they have gluons, muons, luons, puons, underons,
peons,
plebeions. It's why? Why?
Because they
what
create
is happening?
A particle for each new behavior. So if you think of it from the perspective that I'm giving, which is, so de Broglie-Bohm, the pilot wave theory then also implies all the other things that I was saying about ether. That, in other words, everything that we're doing, and the reason why Einstein talked about an ether is because once you start to understand that there's all of this, then you're dealing with these abstractions that are behaviors of this primary substance, or what people call the quantum vacuum, or there's a lot of different names for it, but it's all the same thing. So whenever you see these behaviors and you've been describing them as particles, and whenever you see a new behavior, you give it a new name as a new particle, because the particle is an abstraction for behaviors and for sets of behaviors and for combinations of behaviors. And that's what a phonon is it's a set and combination of behaviors that have to do with real transition points. And what I mean by this, now this is important, is understanding this. And I'm going to, if you want to take something that is kind of arbitrary, like whenever I talk about gallons, it's like, oh, that's just arbitrary. It doesn't have real effects like a photon has a real specific effect of a specific size. It relates to the Planck scale and all of that sort of thing. It's like, so that's why the gallons analogy doesn't work. Yeah, I get you. Because here's the thing. The particles in particle physics are related to specific behaviors, but they are related to transitions. In other words, they're changes from something to something. Like, if you think about one of the examples I like to give is, if you think of like these moai, from Easter Island, those big tall statues. Say a half submerged one in the ocean. As the waves come up, let's say the waves are just not quite enough to knock one over. They're just not high enough. But if they were to get higher, they'd knock them over. Anybody can see that in their head.
Yeah.
And say I set up a whole line of them. They're all side by side. The ocean waves come up, smash against them, may tip just a little bit. They don't fall over. The wave gets bounced back. So there is a point at which just the wave height has to be just enough that it'll knock all of them over, right? If they're all in a line. Instead of having them in a line, let's line them up in a weird way that makes kind of a funnel shape. Now what will happen is waves that are very low amplitude, will come in and get funneled to all the way to that back one at the very point. And so the wave height will grow and grow and grow and grow. So that means that dependent on the shape of my moai statues I have half submerged in this water, I could make it so that if I knew the amplitude of the waves coming in, I could make a funnel kind of shape of all my statues that I've got placed out there, to where the wave would be just enough energy to knock over one single moai. And I could, so that would be a transition, that would be a specific amount that was related to an effect. So that's what we do in quantum mechanics, is we create particles that are related to transitions.
Oh, that's why there's so many. Oh, that makes
Yes,
so much
they have
more
to do with
sense.
transitions from one state to another. So one of the ways that I also kind of jokingly talk about it is you know how there's moles as a measurement, like 1 mole of well, let's say if I were to, there's a let's say there's a certain amount of energy that is required, heat energy, that between the frozen state and the boiling state of a of 1 mole of water, and we'll call it a shrew. So now,
Could it be a gopher?
I don't know. Gopher's a little bit big. I like moles and shrews. They're very similar. So 1 shrew of energy.
Will it be tamed or?
So I could sit there and add a certain number of shrews to a pool based on the number of moles of water.
That looks like a fuzzy cuddle puddle to me.
And at a very specific point, a certain number of shrews added will cause it to freeze or cause it to boil, and so it'll make it look like shrews are an intrinsic part of reality, because when I add a certain number of them, it changes. It does this change.
Shrews change reality.
Yes.
They have magical powers.
They have the ability to impact reality, so they're real. They're a real unit.
It's kind of like Kagebushin Jinsu. When you have like so many shrews together, they perform like a mantra dance. And if it is like 5 shrews, it freezes. If it's 10 shrews, it goes...
It boils.
It boils, yeah. They're shaman shrews.
So the point is, you can tie an arbitrary unit to a very specific transition, and then that will make you think that it has some sort of physical existence.
Kind of reminds me of determinism, that flies come from meat thing.
And that's what happens with phonons, is that there's a certain amount of energy that's either going to bounce back in one way or transfer across a border that has to do with the crystalline lattice. And whether it bounces back or continues forward, that transition is an important part of the way the dynamics of the waves are going to occur in that crystalline solid. And that's why phonons are a very useful abstraction, but they don't exist. So there's no reason why photons and a lot of the other particles may be just like phonons. There's no reason why they couldn't be that. But the thing is, then we have to talk about the difference between massive and energetic particles, and it's a whole lot of other things that describing how these things would work in a fluid medium is a very big and long subject that goes back to very old physics. But the thing is, the way that physics has unfolded with fluid dynamics, with knot theory, with a variety of different things that came from our older theories, there is a way we can take all of the advances that we have today, and if we simply understand that constancy is an illusion in special relativity, and then we understand that all this other magical shit, like, so for the constancy, by the way, that's completely magical. A lot of people don't understand the constancy of light is completely a magical idea and does not fucking work. And that's why Einstein abandoned it by 1912. That's one of the reasons why. But the point is, constancy does not work. There's no reason to be continually defending the idea of light speed constancy. Even Einstein no longer defended it before general relativity and after general relativity.
I wonder if that has something to do with the whole wizard thing you were talking about earlier. Is that a lot of these scientists were nerd kids first, and they wanted Star Trek and Star Wars, and having light constancy is a magical, spacey, futuristic, whoa man, mind-bending.
It's what gives you all the magical shit in physics.
Right.
It's if you
so
take
that's
it
why
away,
they might want to hang
all
on
the
to
magic goes the fuck away,
and then it becomes boring and
mundane
and difficult.
And that's the thing.
And difficult.
And you don't get the magic, but all of it works, and it all works the same. And it's just a removal of a concept. Right. It's not a removal of anything else. That's the point, is that the math still fucking stays the same.
Yeah.
And you just get rid of the fucking magic, and suddenly there's more information available.
They
And
just
then
need it.
and we can suddenly we can advance in a variety of ways once you
And
remove all this magical bullshit.
and that's why it's not boring, and they need to realize that you could actually craft
Exactly.
your own
And complexity,
sci-fi.
hey, complexity is close enough to magic. And I think that's where they're going to get their magical rocks off in the near future. Is emergence, complexity. That shit is practically fucking magic because it's so goddamn complex. And understanding the way that it comes together, it's like for instance, talking about holograms. Holograms are so counterintuitive. The way that they work is fucking cool as shit. They're practically fucking magic. And understanding there's a whole other level of stuff where we can get our wow, that feels like really cool and magical. Like we can get that as long as we throw away our current magical belief system.
Right, and that way we could actually craft our own sci-fi future. Because 2016, where the hoverboards at? Well, if you let
Where the
go of
hoverboard's at, people still believing in constancy.
exactly, so you
People
let go
still
of
believing
that,
in spooky
and
action at a distance. That's where they are. They're not there because of that. We would be manipulating the quantum vacuum. We would have ether-based technologies. We would be able to understand how to get 0 point energy. We would understand all those damn things because we'd be working on them because we know that ether is real, just like Einstein said, just like so many other people have said that are Nobel Prize winners, but nobody is. It's because they're hanging on to the goddamn magic.
and or being kept from actual cutting edge research because
I don't know.
that's a
I'm
national
gonna
defense.
do the never attribute to malice thing, but I know I'm actually.
Speaking of never attributing to malice, I want to cap off the show with going back to the news thing. I didn't find this earlier, my bad. But this goes back to we're talking about moon and SpaceX and things like that. So on one hand we have Elon Musk, and on the other hand we have Jeff Bezos, the Amazon and now Whole Foods CEO person. Well, Amazon owns Whole Foods, but he is Amazon CEO. Or owner or whatever the fuck. So apparently, this is an article from Motherboard that Jeff Bezos' pet airspace exploration project is planning to send several metric tons, quote unquote, of unspecified cargo to the moon in the next 5 years. But that's not suspicious sounding at all.
No, he's been talking about creating moon bases and
Yeah.
stuff. Actually, I've been very impressed by Bezos's focus on like reading some of the shit that he's had to say and stuff like that. It's one of those things where he seems like he is focused on the long term survival of mankind in a certain way.
That's
And
nice.
the fact that he just pledged to all of his workers are going to get $15 an hour. So all of that kind of shit. It seems like he may be working towards goals that he thinks are very important. And sometimes that if that's really what he's doing, then that's one of those things where
More
it's
power
like
to
that's
him.
the people who have vast amounts of humanity's resources. If they are taking responsibility to use those in a way that will benefit mankind, then that is, in my opinion, what makes them worthy. Not it certainly isn't. Oh, he came up with a fucking website and it was shit out in the right fucking place, the right fucking time. That's meaningless. But when they're actually taking responsibility for the stewardship of mankind's energy
Wealth.
that has been funneled in their direction by circumstance, then they are deserving of it. And so it's like I've just recently been reading up on Bezos, and I've been pretty fucking impressed.
So if you'd like to follow the development of that yourselves, you could do it on Twitter actually at Blue Origin, and it is his company, which described by Bezos as quote the most important work I'm doing, end quote. So the Blue Origin signed a letter of intent with German aerospace companies OHB Space Systems and Security and MT Aerospace at the 69th Annual International Astronautical Congress in Germany, and this was just on Tuesday, so this just happened. On OHB, blah, 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 they dubbed the lunar project the Blue Moon mission in the press release because Blue Origin is his company. and Blue Origin, like the little blue dot.
Mhm.
Blue Origin indeed. It's not clearly exactly what cargo the Blue Moon mission would transport, but it likely includes infrastructure designed to start private businesses on the moon. The IAC also installed the launch of the Moon Race, a competition between Blue Origin, Airbus Air and Space, and other agencies around the world to develop technology that will bring companies around the world to the moon. And that's a thing that happened. So, according to the press release, the competition could involve manufacturing products and technology, manufacturing energy sources for humans to survive, getting access to water and sustainable biological life, such as plant or agricultural life, all on the moon. And I would like to add that this paragraph right here is exactly what we need to be funneling money towards, because this could be the conditions on Earth in the near future that we will need a competition. We need a competition to manufacture products and technology and energy sources for humans to survive and get access to water and sustainable biological life, such as plant and agriculture, in the next 50 years. This may be a necessity not for the moon, but for Earth.
Is this supposed to be on?
Nope.
Oh, okay.
It's only doing the sound, so. I saw your concerned look, but
Oh fuck, not again.
no, I've learned from my mistakes, and I've had a live dashboard going that gives me, all
Okay,
the information that I need. But yeah, we sorry guys, we're still getting through some PTSD. Well, not we, him. Master's getting through some PTSD still, because I launched a stream of our quantum physics pilot wave explanation, holography actually explanation, the CherrySTEM 27, the one before the quantum physics multiverse one. And all of these are available on patreon.com/AnnaCherry or youtube.com/AnnaCherry. And the CherrySTEM podcast. So we filmed, or broadcast rather, for about an hour and 15 minutes or so before I realized that we were not broadcasting at all anywhere. And it was somewhat traumatic, shall we say.
It's basically the broadcaster was going, but somehow the stream was
not going to
properly
YouTube.
connecting to YouTube.
Right. Yeah. The stream started, and then after the intro music, it cut off, and then I restarted it, and it was streaming to somewhere.
To outer space.
And so all I ended up having on the channel was 8 minutes of intro music. So
It's okay. It was a great dry run, man.
It was. I learned so much.
It's so good.
Yeah.
We redid.
It's true. We really did it.
We had a practice run of that one.
And it was necessary apparently, because you can only spontaneously talk about the most complex physics concept so much. It was specifically the holonomic brain theory, I believe, and the title of that stream podcast episode is the spiritual interpretation, or sorry, the neoclassical physics interpretation of spirituality. So it is a way, essentially, as we hinted at earlier, to use physics to interpret phenomena that have previously been reserved to the realm of the spiritual or the religious or the paranormal. However, there are ways of adapting this theory, which essentially would be a unifying theory of everything, which science has been saying, physics has been saying it's been needing it for a long time. So, well, not for a long time, but very actively for, because a long time in physics, that could be like, what are we talking, 20 years, 80 years? No, this has been, 5 to 15 years, especially in the past 5 years. There's been a lot of talk on the need for a unified theory of physics, and, essentially a theory of everything that connects things, because we have disparateness
Disparities.
disparities
Well, I mean, the
between
idea of a
the.
unified field theory, that was from like Einstein's time. That was something that, and now these days people are like, oh, you never do it. It's a fool's errand kind of thing. It's like, no, not at all.
Well, there's a call for a revolution, and
It's a call for, yes, there's definitely been a call for revolution given all of the different crises that are.
disparity. Yeah, they call it a model crisis, which is what I was referring to in saying that there are disparities between um, different findings, or rather theories. So we say that we have the quantum theory, and then we have the general relativity, special relativity, and we have all sorts of other things in quantum theoretical physics, such as string and multiverse and what, who knows what else, and all of it doesn't quite paint the same picture. There are disparities between.
I was just reading.
There are disparities between what the models show reality to be, and it's like, well, which one's the right one? How do you, and if this model is right for its corner of the universe, and this model is quote unquote right, or explains the findings of its corner universe, but then the models don't mesh together, like, what do you do? Doesn't it make sense, for if we truly do understand it all, for it to have one theory that explains everything, and connects all the things, but of course that could come down to a difference of opinion between, is reality truly deterministic, or do things just, I don't know, spontaneously happen and have no connection between each other? But we know enough about other complex systems, such as the way the neurochemistry works, the way biology works, the way evolution works, that everything is interconnected.
Yeah, I guess one of the things I haven't pointed out before is the idea of there being a causal
Hierarchy.
yeah, well, okay. So there's something called a strange loop by Douglas Hofstadter, where it's difficult to determine what is the cause, because one seems to cause the other, and I believe that the
I believe it is called
solution.
I Am a Strange Loop.
No, it's the I Am a Strange Loop is the name of a book,
Right.
but it's the Strange Loop is the concept he introduces in GEB.
I see.
Yeah. So I think the answer to the whole question of free will and things of that nature will actually come down to understanding all of reality as like components to a giant consciousness. And so therefore, just like you don't make decisions about each one of your cellular processes, your cells make those decisions. That there are aspects of reality. Okay, well, like for instance, hunger and things like that sort of change your behavior as a human. You think of yourself as in control of your body, but your body is very often in control of you. And so I think that when we start to try to want the idea of free will, that we're kind of missing the interplay between the highest levels and the lowest levels, and that we on a lower level of the universe actually play a role in the decision making process, so that free will isn't it's obvious when you look around you how much shit is impacting your behavior, limiting the scope of the possibilities of what you could really decide to do. And when you start to understand the brain as a machine, then the idea of free will seems to become absurd. But I think that actually it's just the problem is thinking of yourself as a separate entity from the rest of the universe, and not understanding that tangled hierarchy between how decision making processes work. And this is very difficult to explain in any terms other than the way that holography.
Right.
Understanding holography really is. That's the only way I could say that is the very best way to understand extremely complex aspects of reality. But
and you can try to do that along with us in CherrySTEM 27, where we went over holography.
Cool. How well did I go over it? I can't remember.
I thought it was really great.
Okay, good.
But I don't know. I did also have a primer of the failed broadcast. So I listened to it twice. I listened to it twice, guys. That I will recommend
Well, I mean,
downloading it.
I did give the link for that little, because that's a helpful. I love that little.
The CIA article?
No. There was an article that just how stuff works.
Oh, yes.
I thought that was a very good little description of the way that holograms work. Um, I mean, you have to understand more about wave mechanics and interferometry and shit like that, unfortunately, to really grasp it. But I, which that really is unfortunate. But it is a very once you start to really grok um, wave mechanics in combination with holography, uh, it gives a viewpoint that is just absolutely unique, and really it's a lens of interpretation about all of the various strange and difficult questions of reality that it makes them make much more sense. And the best way I could say that holography is completely counterintuitive is that you got a hologram of a star and you cut it in half, you got two stars. What the fuck else in reality does that?
I still don't
Yeah,
understand
yeah,
that.
exactly. And that's what I'm saying. And understanding that really fucking works. Yeah, I mean, for the longest time, I was like, what?
No.
How? What?
No.
Yeah, I had to look at. I mean,
No.
I've looked into. I mean, okay. Keep in mind, I understand interferometry better than like a
You
tremendous.
wrote a book on it. Well, not really, but close enough, you know.
Yeah, no. When there was
The
no
French,
definition for fringe shift, I was the only place when you Googled
this was like
fringe shift
15 years ago.
15 years ago. My answer was the only answer on the entire fucking internet. But the
15, 20 years
it's
ago.
fringe shift. I wonder if fringe shift still is probably still links to that old shitty ass article. And God, that article is so old and shitty looking. But uh, yeah, so I mean, it took me years to really understand. But even after that, like coming back to it again, it's like it's just so fucking. It is such a unique perspective, and it is such a unique way of doing things. The way that a hologram works is just obviously I can't say enough about it.
You guys have to check it out for yourselves. And yeah, there's an article on how stuff works, as well as a declassified CIA document that has some interesting explanation of it as well. And you could try to find some YouTube videos about it, because it's certainly the forefront of science currently. All the anyone who's anyone in current events, movers, shakers, science wise, like even Elon Musk, etc. We talk about are we living in a hologram and things like that. So there are relations to the all of this, with where we're going with AI and other things. It's sort of a convergent point
Oh yeah, it definitely
of
is.
a lot of fields. So it's sort of at the crux of it, and you heard it here first that it is the future
Hmm.
of science. And that'll be the end for us of the broadcast. Of course, if you would like to join us for an after show chat and ask questions, discuss anything you heard, or bring up news, or something that you have heard elsewhere, yourself to us, feel free to join patreon.com/AnnaCherry. Support this podcast. Um, and I would recommend the Challenger mode. That's the one that unlocks the after show video hangouts. And it's a good time. Some lewdness definitely expected. So check that out if you would like to help us out, make more of these. And if you enjoyed this broadcast, or you found something interesting, or anything at all that came to mind, feel free to comment down below. I
We'd
always
love to
read
hear from you.
I always read the comments. I do. They pop up on my phone. One of the benefits of not having a fuck ton of subscribers and not constantly uploading videos is I can actually manage to read the comments. And definitely give it a thumbs up to this video if you learned something new. Subscribe to the channel so you can keep up with our CherrySTEM broadcasts. We do these podcast live streams quite frequently now, and we will see you tomorrow. No, we will see you next time on CherrySTEM, which should theoretically be next weekend. Check out the description in the low bar for our Patreons and other ways which you can show your support and be awesome and amazing and get cool rewards and help us make more of these shows. Of course, none of that is required. We will continue to make our edutainment, education and entertainment. We will continue to make these shows as long as you keep watching them and listening to them. So please subscribe, give it a thumbs up to this video, and we will see you in the next one.